Good morning, everyone. I've got a lot of slides to go through, so I want to go ahead and get started. My slides will be available. I have a QR code. It'll show up here soon to show you where to get the slides and stuff at. My name is David Lucas, and if you're here for the testing strategies for monoliths and microservices, you're in the right place. Let's get started. So again, my name is David Lucas. I've been in the software industry for a long time, just put it that way. I'm a continuous learner. Mostly since '98 on the JVM, working with JVM languages. Java is probably one of the most extensive one, but in the most recent years, I've been working with Kotlin. I love Kotlin. If you work with Kotlin, you may never want to go back to Java. I play multiple roles on different teams. Some startups, I play every hat. Some teams, I play just an architect, but my passion is actually for enterprise Kotlin microservices. So, this is Stir Track, and I just got to go in this direction. So.
Scenario frequently wreaks havoc with students and equipment.
You are looking at the only Starfleet cadet who ever beat the no-win scenario.
How? There was no way to win.
A no-win situation is a possibility every commander may face. Has that never occurred to you?
As I recall, you took the test 3 times yourself. Your final solution was, shall we say, unique.
How the hell did that kid beat your test?
It had the virtue of never having been tried.
I do not know.
May I ask how you dealt with the test? I would really like to know.
There's no correct resolution. It's a test of character.
A captain cannot cheat death.
On the test, sir, will you tell me what you did?
I reprogrammed the simulation so it was possible to rescue the ship.
What?
You cheated.
As your teacher, Mr. Spock, is fond of saying, I like to think that there always are possibilities.
Your argument precludes the possibility of a no-win scenario.
I don't believe in the no-win scenario.
It's a pattern with you. The rules are for other people. And what's worse is you're using blind luck to justify your playing God.
Then you never faced that situation. Faced death.
No, I haven't faced death. I cheated death. Tricked my way out of death.
David is dead.
And patted myself on the back for my ingenuity. I don't like to lose.
So, if you guys didn't know, that's the Kobayashi Maru test scenario from the Starfleet Academy that Kirk cheated on. But what exactly does that mean for us? So let's take a look at this. So, lessons learned from Kirk. 1, tests wreak havoc. They wreak havoc on your team. They wreak havoc on the QA testers because you're trying to test something, hopefully requirements, and to make sure that they pass and that your system provides something that you want. But sometimes testing is a no-win situation. You've got timelines to meet. You've got to pick the one test that happened to get the most bang for the buck. You're not going to always test negative tests. So there's some things learned there too. And as Kirk did, he thought outside the box. And so we've got to think outside the box sometimes too. How do we test negativity? How do we test things that are going to fail, but you don't want to bring down production to do it? So there's some things that you can do in your toolbox to actually do that. Kirk's big thing, his claim to fame, is he reprogrammed the simulation. And testing for software developers is the exact same thing. We end up, when it comes to testing, unit testing, we reprogram the actual tests to come with certain outcomes. So there's a happy path, an expected result, and an unhappy path. And that unhappy path happens to be things that we want to fail in the system and make sure things are working correctly. And as you saw the Big Apple bite from Kirk, no one likes to lose. So if no one likes to lose, let's do a create quality test to prove them wrong. So today's agenda is going to be basically, we're going to review monoliths and microservices real quick. talk about some common patterns, jump into a light cursory introduction to testing, be a unit integration and end-to-end testing. I'm going to demo some stuff on here since I'm a Java, JVM kind of guy. I'm going to be using Kotlin as my examples. But the information here should apply to any language and any type of software development environment. And then if I have time, we'll go into some other topics. I have some parting gifts. Normally, when I give this talk, I'm expecting one room. Since we have multiple rooms, I'd ask you to log into the Discord server. And I guess at 12 o'clock, high noon, I will go ahead and randomly select a couple of people who are in the list and go ahead and hand out some stuff. I'll mention some of the books later, but there's some books around patterns of microservices from Chris Richardson. I've got one on Kotlin, I got one on JUnit, and I have another one that I started reading from Jeff Fisher about arguing. So, what are monoliths? Okay. Standalone system, yes. If anyone can think mainframe in the back of their mind, mainframe was always considered a monolith. You had a green screen tied to it, and it was a big old system that did everything. One big stone, right? So that's kind of like a monolith. And so the opposite of mono is poly. So polylith, many stones, right? And so microservices are kind of considered the polylith. So a typical a typical monolith may consist of a J2E server. In the Java world, it could be a .NET server. But basically, you have this entire system wrapped up. You've got transaction management. You've got messaging. You've got all these additional parts all thrown in together. And that's great if you have one machine and you have all your stuff wrapped together and deployed, which is kind of how Enterprise Java Beans started. You had this thing called an ear. The ear had EJBs in it for communications, and it also had like web archives in there to display presentation tier. So everything was kind of meshed together. It kind of mimicked the mainframe, believe it or not. So later on, people were like, okay, let's stop doing that a little bit, and let's just break out Java EE out to just its parts. So later on, we got things like we had a presentation layer deployed in a, like a Tomcat server. And then we had maybe a REST API set up in another Tomcat server. And so those are kind of like how we separated things out. And we had like a load balancer to direct the requests and put them in the right location. So here's an example of a monolith and a microservice, kind of side by side. The first example on the left, you'll see monolith. It has like this is a blog. So you have users, threads, and posts, and all those are kind of contained within one server, right? But with microservices, you're trying to scale things. You're trying to get as small of a compartment as you can to deploy so you can ramp it up. You can scale horizontally and vertically, and that's kind of why people started going down the microservices route almost the same time that we started doing cloud services. So you can see that we break this up on the right-hand side. We have users, we have threads, and we have posts, and those are different components that have been broken out of the monolith. But notice that the monolith still had user threads and posts. Nothing really changed there. And if we do our monoliths right, if we need to migrate to microservices, we can do that. So here's an example of microservice flow. There are more moving parts here. As you can see, you've got browsers talking to an application server, and it might be delegating through an API gateway to multiple services. So the patterns are very similar. If you look here, you have like an inter-process communication for a monolith. Everything's kind of internal. So when a remote call hits it from, say, a browser, everything usually is resolved internally. And then you have patterns for microservices, which are very similar, but each call is kind of going outside. This represents 3 different microservices and intercommunication between them. So one of the things that's different between the two is a monolith usually doesn't do a whole lot of distributed objects. Everything's usually within the process itself. There might be some messaging going on and stuff like that, but for the most part, it's internalized. But microservices, that's the opposite. They're usually distributed, which means there's a lot more traffic and more calls outbound. The release cycles are very different too. So for a monolith, you may have a mono repo handling everything, but with a microservice, you might actually have independent teams, and each team will have its own repo, and so the release cycle is going to be more complex. Same thing with resources. When you resource deploy on a monolith, you've got a lot of things you need. Lots of gigs, lots of disk. Usually it's like an EC2 instance or some type of container server that manages that for you. And then you've got the microservice is the opposite end. You have usually an image, and in that image, you're going to have a small component, and that component is what is called by multiple components or from an application server. So what is common between the two? Well, if you look at the old pattern of monoliths, you have like a service registry, like a DNS lookup or something like that, where you actually are looking to find something, right? In the Java world, it's JNDI. I don't know if everybody remembers JNDI from the early days. We came from RMI. Remember those things? We had these lookups, and the lookups allowed us to find where things were located at. And that's kind of migrated over time, and Spring has made a big difference in that. Spring allows us to do dependency injection, so you don't look up as much. Configuration's kind of been removed from you. But there's also other things that are common between the two platforms. Circuit breakers, where you might have a retry logic, and it doesn't matter if it's internal or external, the retry still is applicable, and default behavior as well. Saga pattern, very popular in the event streaming world, allows you to do basically state management. When you go from one state to another or back, you can actually manage how things are deployed as far as transactions, whether they roll back and stuff like that. The Strangler is very popular too. Strangler allows you to put a facade in front of something, and then as traffic comes to it, you can manage where it goes, and over time you can actually shift that to where to strangle out an old system and use a new system. So it's very popular when you're migrating. And again, some of the other traditional things like an adapter, a bridge, proxy, etc. So all these things add up to some common patterns that you're going to see no matter which platform you're using, whether it be a mono or micro. Controllers, they control traffic coming in and dish it out within the local model or services. Service pattern, I'm going to go over that a little bit. Model objects, adapter, etc. So here's some patterns and strategies. If you haven't read these books, I highly recommend it, especially if you're new to software engineering. The patterns book, it's very, very dry, okay? But it has a lot of valuable information in it about, once you read it, you may start looking at the code you've written before a little differently. And so design patterns is very popular. It's old, but it's still useful. The newest stuff, Chris Richardson, he's a big microservice guy. Microservice patterns, I highly recommend it. It's really good. It breaks down things for you. And then there's the other one, strategic monoliths and microservices, that kind of talks more about how to break things out. So typical patterns you'll see, presentation view talks to a service controller, and it interacts with a model or service, right? And then you got these other ones. Inside the service itself, you might have other layers. You may have an adapter you have to communicate to get things from another system, third party, or a DAO, a data access object, allows you to get to a data repository. And then inside the data repository itself, you might have multiple repositories where you have information distributed in multiple places that you have to fetch before you can actually do something. So putting that together allows you to, separate out the service logic from the data logic. So pattern summary here, decoupling complexity and dependency. That's one of the most important things, no matter if you're doing it in a monolith or a microservice. That decoupling allows you to separate classes, allow you to separate functionality, makes things more structured for implementing things, including what we're getting to next is testing. So refactor to use patterns regardless of service type. So why do we test? I'm only going to hear from room 3 probably, but unless you really scream out there in the other rooms, why do we test? Anyone know? Some level of confidence, good. Anything else? Quality, see if it breaks. No surprises, right? You don't want to go to production and find out you broke everything you put in 2 weeks ago. But another side effect of testing, I don't know, how many have read the Dilbert about testing? This is really kind of old, maybe? It might date you, I don't know. So if you read the Dilbert, you're going to find out that basically the manager says, hey, I want a bug-free system. How do I get it? And they're like, okay. They're going to pay me to write tests. So what do? On the far right, I'm going to write me a minivan, basically. So the incentives for testing, you need to make sure, if you're a manager, that you are actually creating good incentives. Because how many tests you write is not going to be indicative of quality. It might be that you assert true on every method and it doesn't give you anything. So some other quotes, Dijkstra, if debugging is the process of removing software bugs, then programming must be the process of putting them in, introducing them, right? So if you don't have time for testing, you don't have time to be confident in your product, and someone mentioned that earlier. The bitterness of poor quality remains long after the sweetness of meeting the schedule has been forgotten. How many people wish their managers knew this one? Yeah. And of course, one thing I want to quote, since this is Star Trek and it's space related, Yoda. In a dark place, we find ourselves. A little more knowledge lights our way. And no, I can't do a Yoda voice. I don't know if Guy can do that, but testing sheds light, and that's the purpose, finding the unknown. So, summary, and why do we test? First impressions, we catch them before the customer does, right? You do not want the customer to be reporting bugs. That is not where you're going to do your best work. That's usually when you have fires and critical tickets coming in, and you're going to fight the whole way too. Catastrophic failures, again, you don't want it happening in production and you accidentally deleted the entire database because you did something wrong with Liquibase. You also want to make sure things test requirements. And if you do test-driven development, that's one of the first things you're going to do is make sure that this new requirement has written a test, and that test is actually going to validate the requirement of the software is implemented correctly. And there might be other things to test as well. You might want to test security, for example. But the important thing is that testing provides fast feedback. If it takes you 3 days to get feedback from your test results, who's going to really care about whether they're getting things done or not, right? 3 days, I'll go take a long break and get back and make one line change and go off again. That's kind of like old days of punch cards, and we don't like that. So we need fast feedback to make things iterative. It's okay to fail, but you want to fail fast so you can change it and fix it and move forward. So here's the pyramid. Martin Fowler came up with this pyramid basically from the bottom up. If you look from left to right, you can see that the time in testing increases. So you got all your units at the bottom, and at the top you have cost to fix. So as you go up the pyramid, it's more expensive to fix something. So at the bottom, unit testing, you realize that I can catch things really quick in a unit test. Usually they should be like really, really fast. So if they are really fast, then basically it doesn't take a lot of time to figure out if things are in good shape. Integration tests, though, you might have some components and boundaries that you need to test, and that will require more setup, more testing preparedness. You may have to have data to go along with your tests, et cetera. So that takes a little bit more work, but sometimes you have to do that because you have things like protocols or versions of mappings and stuff that you have to manage. And then finally, end-to-end, and that's where you actually are testing like an API for the back-end side. You're testing it end-to-end from where the API hits a load balancer and it goes through the system and hits a database and comes back, and you're getting an idea of, one, can it actually run end-to-end successfully? What kind of errors do I have? And then you can do things like stress testing and performance testing from that. So Martin Fowler came up with a couple of things. Mentioned dummy objects, which are kind of like passed around. It could be like a token or something. Maybe it's a JWT token, but you're doing it in a service test and no one cares. So it's a dummy object that no one may never use. Fake objects, they're kind of like a non-prod working object. Stubs, canned answers, you might have simulators that do that. Spies are very useful. They can spy they can wrap around an object, a service or something like that, and the spy basically allows you to see what's going on in the call. You can sometimes fake it out if you want to, but the spy can capture parameters, and then you can actually check to see what those parameters were to make sure that things under the covers is actually doing what you expect. And of course, mocks, and I'll talk a little bit more about those. But basically, mocks are pre-programmed responses, and they can be plugged in a lot of places. But to do the plugs, you need to actually set up your dependencies in your classes and your functions to do this. So if you have a lot of configuration embedded in your classes, it's going to be really hard. That's why dependency injection is so important for unit testing. So things like this example here, we have like 3 different dependencies in the back end. We have mock dependencies that we can put in there, and so the class can now actually test successfully. So unit testing obviously applies to functions and the classes, but the focus should be on they're immutable, the same input produces the same output. Edge cases for mins and maxes and stuff like that should be part of the unit test. Single responsibility principle, if that function is supposed to do that one thing, that's what you need to be testing for. And if there's other things that are happening inside that, it's an opportunity to refactor it out. Use dependency injection to pass context as well. So there might be things where, every time someone puts in a new requirement, you end up with a new parameter on a function. That's a sign you need to put some type of context or an object in there to pass that data structure down. That way you don't keep changing that interface and you allow whoever's using that data further down your system to deal with extraction of it. So in a integration testing type of thing, we have components instead of classes that we're focused on. And so the integration tests themselves should be about how components are working together. It might be something as simple as, can I send a message through the system all the way to a message broker and get the message back? You know, it could be something like that. But your idea behind that is to make sure you're doing more than just like a unit test. You're doing like components, communication side by side. And so when you go to test this, you go to test it, you're going to mock out some of these external services. Now, there's lots of things out there that you can do to mock that out. You could use like test containers and put a real database out there, like PostgreSQL or Kafka or ActiveMQ, some other framework out there. You could embed it and run it within the runtime to talk to it and test the connection and logic and stuff like that. So the demo I'm about to give, and I'm talking quick, so please save questions for the end or put them in Discord. If you already have the Discord set up, go ahead and do that. Definitely going to be some additional information passed along. But in this example, I called it messy in the code. But this is supposed to be like a controller that does everything. It's the Uber controller. You've probably seen one of those. They have all the service logic, business logic, database access, everything within one controller. And that makes it really difficult to test because you probably only want to test like the new function that you came up with, but then you realize, well, crap, I've got to make sure I have data in the database or something like that, and it can be really complicated because they're all intertwined. So unit tests should not do database stuff. Unit tests should be fast and local, right? So when you refactor, you want to break things out to where you have like services that actually are delegating work, controllers that are delegating to services, data layers that are actually being called from the services. So you separate those out and it makes it a lot easier to test. So if there's a bug, you can go look at it. So without further ado, 20 minutes, that's not too bad. My practice was longer, so I apologize for talking fast. So, just to give you kind of a quick rundown here, I'm running a K3's Kubernetes environment where I've deployed a bunch of stuff. Because conferences like this, there might not be a lot of connection, and I do not have a connection here. I use Getty to actually do my Docker registry, so I can build and deploy here locally to that with no problem. Some of the other setups here, let me pull those up. Can you guys see at all? Okay? Okay, good enough? Okay, let me max this out. So, that better? Okay. So I have a Kubernetes cluster. I've got Artemis, ActiveMQ kind of stuff going on in here. I've got my little service that I put up, the controller, it's ATM. I've got Getty running back here with Getty Action. Anyone familiar with Getty? Oh, okay. So it's like a GitLab or GitHub repository. It's really lightweight. It's written in Go. And it provides issue tracking. It does a lot of stuff, including actions. And so basically, I put my Docker container up here, and this is actually a summary of what's in it. So this is my ATM microservice that I created. I didn't break it up further. I just wanted to go through the model. But I could have probably added more to it, and it would have been more time, but we only have 45 minutes. So I use Jib in the Java world to create my containers, and it's actually very useful. So let's go take a look at some other stuff. In this environment, I also have WinMock or WireMock. WireMock is very important for capturing traffic. If you want to like simulate talking to a real service, but it's only available in one environment. Let's say you've got a staging environment that they want to do end-to-end testing in, but you want to simulate some of that stuff in a lower environment. You could use something like WireMock, put a proxy up there and have your traffic go through the proxy, record it, and then copy the information from a file from WireMock export and import that in a lower environment, and then you can play that back. And so if you play that back in, say, your integration test, you are trying to talk to something that looks like the real system, but you're going to get the canned responses that the real system provided. So that way, if you do this like maybe once a release, you record new stuff, or once they release, whatever the third-party system is, you can actually capture this stuff and make sure that you're still using what looks like production stuff in your development environment. In here, you can get all kinds of stuff. You can actually set up things. Let me pull up let me show you some stuff that's in here real quick. Okay, real quick is probably relative. Within this day, Can we get that within this day? Here we go. So here is an example that I put out there. I deployed this just before here, just to save some time. But this is an example of some traffic that was going on. Hello, StirTrack. And if I go over here and run this again, you'll see it refresh. And it says, hello, StirTrack. So that's just one thing that I did. I programmed that, so I was able to use an API that WireMock provides. And I told it, set me up an endpoint that's hello, StirTrack, and provide this as a response. And so it did it. It's already done. Oh, by the way, my local environment is completely insecure. Do not do this in production. SSL certificates are a requirement in a production environment. But for local, it's fine. But anyways, you can see here that this is actually running within the WireMock environment. And you can get information about the request that was made and stuff like that. So there's tons of information. I don't want to stay here. But WireMock has an API that allows you to see into it, change it, make changes as you go and stuff like that. And I'm going to show you that in a demo here. So a lot of the other tools that I have, Portainer is used for Kubernetes for seeing what's going on inside of it. Again, Getty for my repository, Get and Docker images. Artemis for messaging. I'm not going to do that. Mailhog. Let's take a look at Mailhog real quick. Mailhog is something, I don't know if you guys do email still, if everybody's out of the email world. I still have clients that use email. So one of the things that Mailhog allows you to do, and let me stop that and just go over here. Mailhog simulates SMTP traffic and allows you to capture that traffic. So if you're sending something out and you don't want it to go to real production users, even though you might have captured email addresses or want to test sending out emails, Mailhog is a real good replacement. You can put it into an environment and just stand it up, and it'll send traffic, SMTP traffic that goes there will come here, and it has an API that you can actually extract information from it. So you can actually verify the email that was sent and information about that email. So here's a couple examples that I ran. ATM, use alert, thank you for using your ATM card. If it was not, please notify security, blah, blah, blah. But the email is here, and you can actually do an API to check it, and there's headers and stuff in here. And if you put header information here, like this message ID, for example, you can actually go query messages and get them out and verify them on a case-by-case basis, which is really a cool tool for integrations. So that's kind of some of the stuff in here. I got to go and look at some other stuff here. Lost my mini. So let's go look at some code now. So in the world of patterns, I have an example here, and this may not be visible yet. Can you guys see it all? It's tiny. Ugh. You probably don't care too much for the left. You care about the right. Let's go through them quickly. Believe it or not, it's hard to see with bright light shining on you. So let me just run the tests real quick and show you that they still work and I'm disconnected. There we go. There we go. So they all passed, and let's take a look at some of these. So in the world of unit testing, there's some things that I want to highlight, and hopefully, let me move that out of the way. Can you guys see it all? No? Let me make it bigger. Used to know these commands by heart, but I don't use them enough, so. Guy doesn't use IntelliJ, or he'd be telling me what the command was over there. Anyone else? There's a quick view, zoom. There it is. It's under parents now. Full zoom. Oh, it says I'm in full zoom. Well, I don't believe it. Do you guys believe it? Is that big enough? No, it's not doing it. Let me try one more thing. And it might be because I have the other screen over there that it may not use the right resolution now. It's still not giving me what I want. Okay. Just do that. Let me know. It's not doing it. I don't know what's going on. Anyways, can you guys see back there at all? No? Control Shift. Oh, they changed it on me. What editor is this? It used to be plus minus, now it's dot. So, okay. It's the latest version, I think. That's probably why. Can you guys see now? Awesome. Okay, so, whoa.
Hello? Testing 1, 2, 3.
Sorry about that, guys. So anyways, in this example, the email sender, I talked about having the mail hog out there. Well, if you're doing a unit test, you don't want to communicate out to a mail hog or anything else. You want to actually do everything as local as possible. So here's an example. I'm using a mock. The mock is in here. We also have a thing called a slot. And a slot in mocking world is basically something that's going to be capturing data as it processes. So in here, I have a call for a send, email send. And every email send, I'm going to capture this thing in email slot, which is type email. So whatever is being passed into that function for that argument, I'm going to catch and look at, so interrogate. So here's the actual call. So I set up my every for the function call in the mock, and then here I have a notify user. In that notify user, look at this. I have a withdrawal that's going on, but all this stuff is being passed downstream. And notice this is the service. The service itself is using this email adapter. So I've broken things out, I've refactored it, and I've got a service with a constructor. The constructor takes in the email adapter, and it's a mock. No configuration required. So in here, I notify a user, I pass in this information, and what I'm expecting is a really cool send to go out exactly one time, which is another thing you can do with mocking, is you can actually track how many calls certain things happen. You can even put, instead of any that I used here, I can actually put a parameter saying this exact object has to be passed in. So anyways, the exact object being passed in here doesn't matter, so I put any in there, and then I'm going to get the data back, and I'm going to do a capture. So I'm going to take the email slot, look at the capture data, look at the body, and make sure the body contains my test message that I generated. And so that way I can inspect, even though I don't have access to maybe even a private method or something that might be doing the send inside of the notification service, I don't care because I know it's using this adapter, and I've extracted it out, so the adapter is being used to make the email call. Down here is an example of just doing some unit tests with a test factory. Test factory, along with parameterized tests, allows you to repeat things over and over and over with having like a common test objective. It'll pass in inputs and expected results and then allow you to do testing from a stream. So in here, I just basically took all the entries for notification type, it's an enum, and I'm going through and creating a dynamic test for each one of them to make sure that what comes back on the call comes back correctly and is in the expected results. Now, one of the things, I've worked with how many are working with GraphQL? Anyone? Oh, okay, we got a few. So in the GraphQL world, you have to create these enums, and enums are kind of like taboo at times, because an enum, if you're in a GraphQL world, you might have more than one service that might be sharing that enum, and if that's the case, you got to be really careful that you always represent that the same way, or you're going to have problems in federation. Which is kind of funny, Star Trek Federation. Anyways, so one of the things you can do is to make sure that each of your components that are going to eventually be shared inside that federated environment are testing those enums, make sure that the count is the same and the values are the same, because if they get offset, you're going to have a merge conflict within the schema, so your client's not going to be able to see anything, nothing will get deployed successfully, and you want to make sure those are always in sync. So that's one of the things you can do, is actually have a test around enums. So let's go back here and take a look at some other stuff. We did that one. So this is just a simple test also. How many use UUIDs for database objects? Anyone? Everybody just using IDs? Okay, we have a few. So sometimes in your world of development, you're going to realize that if I need to promote data from one environment to another, IDs, identifiers, and stuff like that in your database are going to be problems because they're not going to be the same in every environment. Each environment may have a lot of additional data. So tracking identities and making sure that the sequences are set right in an environment could be really painful. So one of the things to use is a UUID for storing your object IDs. Well, if you do that, the standard object IDs that are created for UUIDs are really random. And if they're random, that means your database inserts are going to be random, because if you're using a key to insert into a partition, guess what? Your data is going to be all over the place. And as some people point out with caching, that's bad because if you have to retrieve that, that's an I/O in multiple locations off disk. So that can, in fact, impact performance. But if you are using a ULID, which is like a UUID, it's more sequenced, it's predictable. So now you have things that are associated with each other. So as you ask for a new ULID, you're going to get a new value that's close to the previous one. So your inserts are going to be co-located, which is very important for performance. Another thing in here is we're using simulated response here to pass in and out, and we're doing some assertion in here. And there's a field in here that we don't want to watch or look at. So some assert frameworks will have the ability to ignore fields, and that's real important to avoid things like timestamps or things that are like index values that are always changing, and you can't predict them when the test runs, but there's other data in there you want to check. And so this is really useful to be able to filter things out. So here's a zip code test that I have set up here, and basically it's similar to others, but this one has a JUnit perf test on it. JUnit perf is about testing performance. This one I can do in a unit test with no problem because it's an object that's going to be commonly accessed, but it doesn't have anything back-end stuff. But if you had back-end things, then you'd want to move this JUnit perf to either a performance directory or to an integration test. But the idea behind it is that you set specifications around the test itself. So down here, there's a JUnit perf test set up, how many threads I'm going to run with, what my duration of the test is going to be, 1 second warm-up, a total execution 1,000 times, and the max executions per second is 1,000. I don't want to suck up all the CPU on the machine, but that gives you an idea of what's going to happen. And then down here, we have percentiles for pass-fail. So on the requirements, and this is 90th percentile, 95th percentile, 98, et cetera. So when you run this, you can actually see the different percentiles broken out and whether it met it or not. So it's going to run, ramp up, and execute. And you can see the zip code lookup is pretty fast. We ran with 4 threads, no errors, everything passed. We had 1,003 invocations. And you can see here that it was throughput of 111 transactions per second, and my requirement was 100. So I passed, yay. If your system's getting slow, let's say you're deployed to a CI pipeline, your runner is slow, this could come up as a failure, and you don't want everything to fail, so you may want to put this in its own package for performance testing only that's done at a different time. So other tests. In here I've got a couple of tests, a zip code test. Let me find it. It's in here for parameterized. Here we go. So this is a parameterized CSV type layout. I don't know if you can see it right here. There's a value here, zip code followed by a city and state. And yes, I do live in Pataskala, so please bear with me. A lot of these are Ohio derivative, but anyways, I've got a couple other tests in here just to show what would happen. But basically, the test lookup runs, but it runs based on this input value, and the results are going to be trimmed and tested, and basically, if I run this, it'll run those. Now, I have another test in here I disabled. It takes about 20 or 30 seconds, but it runs through an entire zip code list, and it's a lot of things. So you might want to put this particular test in an integration test because it might run a lot longer. So anyways, moving on. Some other tests, let's go to integrations. So now in the integration world, I mentioned WireMock, right? You guys remember that? This email adapter in the integration tier is actually going to use an instance of MailHog. And in here, you can see that there's a MailHog client that was created. It's going to get a request based on what was passed in. It's going to look for the value from the body to verify that it got what it was looking for, and then it's going to pass or fail based on the data that came into it. So this little fetch in here allows us to actually send something out and verify that it successfully got in the email server, it passed the SMTP protocols and stuff, and that's actually going to be going where it needs to go. And that's using the MailHog as well. And let me go to the next one. This is anyone see the Star Wars API? Anyone used that before? So Star Wars API is really cool. Someone put it out there with all the characters of all the movies from Star Wars, a lot of things like spaceships, planets, stuff like that. But I'm offline. Notice I'm still offline. So what I did is I used WireMock to record that information and do a couple of tests with it, right? And there's a file that's created, and I put it in my resources so I could pull it up. It's API Starships. It recorded the queries and returned a result here, right? So that's pretty much it. But when I run it, it's going to start, besides the REST client, it's going to actually start up, where'd I go? There it is. So there's a WireMock configuration, the WireMock server. So this is an embedded WireMock instance. It's going to come up with the configuration of being inside the system itself. It's going to use a local port within the Spring Boot test. And it's going to use that to communicate what is happening with the results of the query and stuff. So if I send it something that's not mapped out of the stubs, it's going to fail. But if it's mapped and it does the right thing, it's going to come back with the right values. So let me just run that real quick. And presto. So this ran out, it created its own server, talked to it, and it just came back. And I don't know if there's anything really in here to show you other than that it did it. Moving on, we have a controller. So one of the things I talked about in the controllers was the refactoring and stuff like that. So if you look at this controller, you'll see in here that we have just 2 parameters that come in, the services themselves. The original messy one that I was going to show you if I had more time, it was actually like had everything embedded in it. I call it an Uber controller. It's got everything in the world. So every time someone makes a code change, everybody's fighting for the same file. That's bad from a team perspective. One person, not a big problem. Multiple team, big issue. So you break things up into services, and under the services you actually can break things up further, and have DAOs and stuff like that. And that actually helps you break the tests out so you don't step on each other's toes and stuff like that. So in this test as well, we've got just save, regular CRUD type routines and stuff like that. And we've got things in it. Let me move on because I'm now running out of time here. Spring Boot test, that's probably not as important. So let me show you some other things in here. So one of the other things I mentioned was like testing APIs. So everybody wants to test APIs. Let me pull up Insomnia real quick. So Insomnia is a really cool tool. Postman does a similar thing. They're free. Usually they're easy to learn. This one example has a bunch of tests in here. There is a framework inside these that you can script, and you can put things like how to do things afterwards. Like I can make a call, test it, return with a 200, and then I can do something like actually checking like expected values and stuff in the script itself. So when I run this, I can see it going out and stuff, and it's talking to the back end connection. It came back, and you can see the test passed. So this test here was actually ran as part of these connections. You can see there's a standard post and stuff like that, nothing fancy there. So if I export this, I can actually create, after I run this test, I get things manual, so I'm happy that my end-to-end tests, I can show that they're working, right? So I can export this and bring it up in, let me do this inside. How are we doing on time? Okay, 3 minutes, can we do it? Pressure's on. Can I get a Jeopardy song? Come on. Yeah, I got to go down here to performance. So let me launch. I don't hear any songs. Let me launch this JMeter program. Here we go. Okay, so JMeter is coming up. Now I've already, as part of the parameter on this function or this script, I already set it up to load. I don't know if you guys can see this, and I probably don't have ability to view change here. So anyways, what I'm going to do is I'm going to launch this. It's going to run. It's going to start talking to my 2 ATM containers that are running, microservices are running out there. It's going to start calling and stuff like that, and you're going to see here traffic. Now I've got one failure test up here. It's going to show me that failures are really happening, and it's the login failure, and everything else is running pretty much the same, and you can't see. But if you could see, you'd see that everything is passing successfully. So I'll just go ahead and skip that and get back to the slides, and we'll wrap it up. And I need to stop this before it goes any further. Okay, so this is going to be fast. Back to the slides. So use test factories. Parameterized tests are very useful. A copy of these slides are available, so I'm not going to read them to you. You can go through them later. Fake data generator is important, especially if you have sensitive data in production. You don't want PII to get into the development environment. You can generate these to generate the structures for you, so you can do production-like testing without production data. Set up mocks before each, not afterwards. Clear and reset after each step. If you're doing data testing, I usually like to do my pre-step to do deleting of data so I can actually interrogate it after the test. Components under test, we kind of talked through that. End-to-end testing, verification of front end is usually something like Selenium. We've talked about JMeter, using that, and Insomnia. We talked about performance load. Oh, yeah, I was going to show you that, but I ran out of time. Anyways, that's it. Please jump into the Discord server. You'll be able to get the slides and stuff like that. I'll post that. There's a link on here for the QR code. If you grab that QR code, it'll take you to my GitHub repository, and that will have the slides and anything else we decide to put in there from the Discord server. Again, I ask everybody to log in Discord. I'll take a list of the names that are logged in there, and I will go ahead and give away a couple things. There's a couple books that I want to give away. Microservices, JMeter performance testing, and Kotlin in action. Those are the 3 books I plan on giving away, and I have a 4th one. But anyways, I want to thank everyone. Thank you, StirTrack, for allowing me to speak, and hopefully you got something you can take away and go back and work with your software project. Thank you very much.